wording on this. So anything that's correct?
Yep.
Okay. Let's talk about completing the square.
Okay.
All right. First of all, here's our function. And what's the general format for the vertex form?
I'm not really sure.
Okay, you need to memorize these.
Okay.
Because that's the starting spot for every problem, is to know what the general format of it is. If you don't know that, you really can't do the problem. I mean, you got no chance. Okay? So that's the general format of the vertex form of a quadratic. H is the x-coordinate of the vertex, k is the y-coordinate of the vertex. So this is probably the most important format because it immediately gives you the most important information of that parabola, which is its vertex. So we have to make our equation look like that. Well, it doesn't look like that at the moment. But one way to do it is by completing the square, and you complete the square by putting both your x terms together and leaving this 2 outside like that. Now, how do you complete the square?
You divide -16 by 2 and then square that.
Okay, and that's always added because whether it's positive or negative, it's going to be a plus. What do you get?
64.
Okay. Now, I just changed the equation. Before I wrote that 64 in there, it was identical to my number 1 row. Okay?
Yeah.
I cannot change the equation. So because I added 64, what else do I have to do? And I want to do it on the same side as the equation.
Subtract 64.
Yeah, now those two equations are exactly the same. In other words, number 1 is the same as number 2. And when you're doing these, it's always, I think, if you want to avoid mistakes, you always do this check. You make sure that you have not changed the equation from your original. Notice that if I can cross out these 64s and I'm back to exactly where I started. Now, the reason you complete the square is so that you can write this term as an x minus h quantity squared. Well, what is this quadratic that's in parentheses? What's it going to be? It's going to be x what? Minus what?
8.
Yes, whatever you got, when you took half of that coefficient, that's what you're going to write in a linear term squared. Okay?
Okay.
And we combine the two numbers, so we get minus 62. And now look what we have. We have it in perfect vertex format.
Okay.
Where's the vertex?
Negative, or 8, negative 62.
Correct. Okay, I'm going to keep erasing that format because I want you to memorize it, and I want you to draw it out of your memory. So,
Okay.
what is it again?
Y equals A, parenthesis, x minus h squared plus k.
Incidentally, that is the best way to memorize anything. Never have it sitting in front of you and so that you're always looking at it. You know what I'm saying? The more practice you get at drawing that from your memory, much better you're going to get at memorizing it. Okay? In that last one, A was 1. Notice there was no coefficient in front. This is a little different here. We're going to have an A. Okay, first thing, you know what, I'm going to leave it written like that. So, because you always want to be able to check to make sure you haven't changed the equation from step to step. So, I don't want to erase that one or do anything to it. Okay. Now, there's a rule about completing the square. And that rule is that you can only complete the square when the coefficient of this first term is a 1. So what do I have to do as a first step here?
Factor out 2.
Only from these first two terms, yes.
Yeah.
And always be checking. Make sure that what we now have is what we started with. And it is. If I distribute that back together again, it's exactly the same as what we started with. Now, complete the square inside the parentheses.
Just add and subtract 9.
Okay, there's the adding of the 9. Only thing is, when I wrote that 9 in there, how many did I actually add to the right side of the equation?
3.
That 9 is being multiplied by a positive 2, so I really added 18. This equation is now 18 more than what it started with. So, I got to subtract 18. So whenever you have to factor something out of those first two terms, always make sure that when you write in the number that completes the square, that you're multiplying by that thing. And if it was a negative sign, then you've subtracted 18. So you'd have to add 18. You always do the opposite on the same side of the equation as what you did. Now, if you go back and you compare this line here that I've check marked, you'll see it's exactly the same as the one before it, and it's the same as the original. And I cannot stress that too much. If you want to not make mistakes, this is the only way to do it. Okay? If you wait till you get to the very final step and you have a mistake, you're not going to find it. It's going to be really hard to find. You're going to basically have to go back to the beginning. You're not going to know you have a mistake. So this method of checking as you go is critical. Now, how can I write this quadratic in terms of a linear term squared?
2x plus 6 minus 18.
No, it's not 6. It's what you got when you took it.
3.
Okay.
Yeah.
And it's plus. It's the same sign as whatever that middle term is, always. In other words, in the previous problem, the middle term was minus, so that it was an x minus 81. But this one is plus. So how much? And then when I combine those two, I get that. What's the vertex of this one?
-3, -23.
And this one is going to have a vertical stretch factor of 2. That's what its A is. Whereas the previous one, we didn't have to factor a coefficient out, and so A was 1. But they don't even want anything but the vertex, so we've got the vertex there. All right. Sure you don't want to look at 50? I see others here that I'm certainly willing to go by what you've circled, and especially since there's probably tons of material to cover and we got an hour and a half, so perhaps what we should do is go ahead and go with the ones you've circled. and then go back. I'd be surprised if you didn't have a problem with 50, only because word problems tend to give everybody a hard time. And
Yeah.
they're not that easy, although once you do these kind, they actually are pretty easy. In other words, how long does it take the penny to reach the ground? Well, that's when h is 0.
Yeah.
Just substitute 0 and solve. How long will it take the penny to reach the bottom of the well? Well, that's when h is minus 100. So you plug in h of minus 100 and solve. But, okay, I can appreciate that these are going to be kind of hard. So let's do 51. Use the distance formula to write an equation of the parabola. Okay, well, here's what they mean. It's a fairly hard problem here. I'm going to put the focus right there. Which way does this parabola open, up or down?
Down.
We don't know yet until we put the Directrix in there. In other words, it could look like this, or it could look like that. Because all we know is that the focus is always inside the parabola. Just having the focus doesn't tell us much. Now, with the Directrix, y equals minus 3. Hold on. Sometimes I hate this program because I accidentally leave it and erase. Well, y equals minus 3. That's the Directrix. Now that tells you where the vertex is. Where's the vertex?
The vertex is 0.
0, 0. Right there. And now we know it does open up. In other words, it has to look like that. Because we know the focus is inside the parabola, so it has to open up, not down. Now it says use the distance formula to write an equation of the parabola. Well, let's put a point right there, and we're going to call that point x, comma, y. Okay. Now, the definition of a parabola is that every point on the parabola is the same distance from the focus as it is from the Directrix. Notice that if we were at the vertex, we'd be 3 units away from the focus, and we'd be 3 units away from the Directrix. And this is when you draw the Directrix perpendicular, or when you draw that distance perpendicular to the Directrix. Obviously, if I draw that at an angle, it's not going to be the same distance. It's going to be longer. But that's the true definition of a parabola. Every point on the parabola is equidistant from the focus as it is the Directrix. Okay? So, I can figure out what the equation of this thing is by saying the distance. What's the distance from 3 to that point?
Is that 3 units?
What's the distance formula? I made my mistake by not always beginning with the distance formula. What's the general for the distance formula?
I'm not sure.
Should your teacher allow a cheat sheet?
No, but I have to memorize all these tonight.
Boy, you sure do. Let me give you a clue about memorizing. Best thing you can possibly do to memorize stuff. Get you some index cards, write out the key things to memorize. In other words, you would have one index card that said distance formula on one side of it, and on the other side of it, it would say this: x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. The square root of all of that is the distance between those 2 points. Now, if this looks familiar, that's the hypotenuse of a right triangle. If I have a right triangle and I want to solve for z, well, and this is a and this is b, well, z is the square root of a squared plus b squared. And notice that b squared is the difference in the x-coordinates, a is the difference in the y-coordinates, and so these two things are the same basically, and the reason is that the distance between 2 points is always the hypotenuse of a right triangle that I would make. In other words, if I draw a right triangle there, that distance from that point 3 to this point, x comma y, is the hypotenuse of that little right triangle I've created. And it always is. Not always. You'll see that the second distance is not the hypotenuse, but far easier to figure out. So let me erase this, but that's one way to memorize the distance formula, is if you know how to solve for the hypotenuse of a right triangle, that's what the distance formula does. Okay? So I know that distance 1 has to be equal to distance 2, correct?
Yeah.
Okay, well, d1 is the square root of x sub 1 minus 0. I can do these in any order I want, incidentally. I can do x sub 1 minus x sub 2 because I'm squaring it. So if it's negative instead of positive, it doesn't matter. So that ends up being x minus 0, the x-coordinate of this point right here, the black dot, is 0. So that's squared, plus y minus 3. The y-coordinate of that black dot squared. Okay?
Oh, yeah.
That distance is the same as d2. Well, what is the distance for d2?
-3.
You don't need the distance formula here because this line is not the hypotenuse of anything. Just take the difference in the y-coordinates. That's the distance, right? There's no movement in the x direction, so the only distance is from that spot, which is y, minus a minus 3. So that distance is y plus 3.
Oh, yeah.
Okay? Like I said, this is not a particularly easy problem to do, but now we're there. Now we have the following. We have the square root of x squared plus the quantity y minus 3 squared, the distance formula for the other, and that's equal to this distance, y plus 3. Well, now is all I have to do is square both sides, and I get x squared plus this quantity, y minus 3 squared. In other words, I remove the radical sign. And over here, I get y squared plus, plus 6y plus 9. In other words, I got to square both sides. And now I'm going to go back and expand that. Should have done it the first place. I just wasn't sure I was going to need to. Y squared minus 6y plus 9. And I don't need those parentheses. Oops. And all of that's equal to y squared plus 6y plus 9. Well, help me solve this equation.
Oh, yeah. Subtract y squared on both sides. Add 6x on both sides, or
There's something
6y?
there's something else we can subtract from both sides. This number 9.
9.
Whenever you see the same thing on both sides of an equation and it's being added or subtracted, like that. Now, I can't do that with the 6y's because this is a negative 6y. That's a positive 6y. Okay? But I can move that 6y to the other side, leaving x squared equals 12y. Well, there's the equation of my parabola.
Oh, yeah.
Okay? And not only that, but it's in the proper format. I presume you've learned this format. 4py equals x squared, or x minus h squared if there's an h and a k. Have they taught you this?
I don't believe so.
So they give it to you in the vertex format, and they tell you that a is 1 over 4p?
Yeah.
That's the way they do it?
Mm-hmm.
Okay, that's interesting. Okay, so if I'm going to do that here, then I don't leave it in that format. I leave it in this format. Y equals 1/12 x squared. And there's A. And if I know that A is equal to 1 over 4p, this is the way they're having you do it?
Yeah.
That means P is equal to 1 over 4a, if I just do the algebra here. P is my focus. Okay? So by writing it in more standard format, vertex format, you can still figure out the focus. And if I let P be 1 over 4a, then I end up with 3, and I know that that's correct. They've given us the focus, so I know it's got a length of 3. All right. Now, let's have you do one and see if you can do it in the same way that I did it. Okay. Draw your picture. Identify your vertex. Identify your focus. Is this open up or down?
Down.
Now, I can use the same technique exactly, but I got to draw the directrix in there. They didn't give us the directrix, but they gave us enough information to where the directrix goes. Where does the directrix go?
0, 4.
A horizontal line. It's always perpendicular to the axis of symmetry. Okay, now let's take a point over here, anywhere on the curve. Again, we're going to call it x comma y. And now tell me what to do.
You find the distance from -4 to x, y to the directrix.
Tell me what that distance is. Here, let me scroll down a little bit. This is 4 up here. Okay, so D1, we'll call this, let me work in red here. This is D1, okay?
Oh, yeah.
It's D1, and this, drawn perpendicularly, is D2. And we know they're equal. So tell me what to write.
You have to plug those into the distance formula.
What's the distance formula?
D square root x2 minus x1 squared plus y2 minus y1.
Use it in this context. In other words, we have an x, and we know the x coordinate of that point. We have a y, and we know the y coordinate of that point. So what is the distance between that point x comma y and the focus?
X plus 4, x minus 4.
Hold on. You're subtracting the x coordinates of these 2 points. What's the x coordinate of the focus?
0.
Okay, so it's x minus 0 squared. Plus what?
X plus 4.
The other variable is y.
Yeah, which is negative 4.
Okay, so y minus a negative 4, so it is y plus 4 squared. Okay, and that's D1. What's D2?
The same square root setup with x minus 0, x minus y minus 4.
Well, D2, we know that y is negative, right?
Yeah.
In other words, it can't be y minus 4 because we got to get from this y to there, and then we have to add that 4 to it. So it's got to be y plus 4. In other words, this is a y distance right there, right? And we know this distance is 4. So think about doing it the other way. It would be 4 minus a negative y. We can see that y is negative. It's below the x-axis. So let's do it this way. 4 minus a negative y, that's that distance.
Yeah.
And you can see why it's not y minus 4. Y minus 4 would be a number smaller than this distance is. If I break that distance down into 2 parts, well, that part's 4, and this part is y. Well, I got to add those two to figure out what D2 is. All right, we've done the hard part, which is setting up the equation. Now let's do the rest of it. It's the first step. In solving this equation. Once we solve this equation for y, we'll have the equation of the parabola. We know what an equation of a parabola looks like. It looks like something like this, right?
Yeah.
And they probably even taught you about horizontal parabolas where it's x equal y squared. But so we've got all the makings of what we need. We got a bunch of x's and y's. Let's solve this thing or simplify it or manipulate it so that we come up with something else. Because at this point, this doesn't look much like the equation of a parabola. It happens to be just as valid of an equation of a parabola as what we'll come up with. But this isn't the answer they want. What's the first step?
Square both sides.
Okay, which leaves what as the next line?
X minus 0 squared plus y.
Take out the minus 0. We don't need that.
X squared plus y plus 4 squared equals y squared plus 16.
Okay, expand that inside. What's y plus 4 squared?
Y squared plus 16.
No.
Y squared plus or minus 16?
No. What you're making is the most common error in algebra, which is the following. That is not equal to x squared plus 1. It's x plus 1 times x plus 1, which gives you a middle term. In other words, the true answer is that. We'll make sure you do that with these. You can't square something like that and come up with y squared plus 16. You got no shot, Mark. Seriously. you've got to be able to square a linear term accurately. What's the right side squared? If you have to do it this way, do it this way. In other words,
y squared plus 8x plus 16.
Okay. And I'll even write it in the order that they gave it to us, or that I put. Now let's simplify that. Can I cross out?
Can get rid of y squared on each side, 8y on each side, and 16 on each side.
Yeah, I made a mistake here somewhere. Let me go back. If we get rid of the 8y and the y squared, we're just going to have x squared equals 0. So that can't possibly be right. X minus 0. It's not y plus 4. It's y minus 4. And it's not real easy to see why that's true, other than to once again notice that y is negative. In other words, the distance between this point that I've called xy and this focus is clearly not y plus 4, because y is negative. So if anything, it's minus 4 minus the minus y. See what I'm doing? Which gives you minus 4 plus y, which gives you y minus 4. So that's why that distance is y minus 4, not y plus 4. And notice what alerted me to my mistake. One of the best skills you can have in math is figuring out when something goes wrong, why it went wrong or where it went wrong. And when you're solving these kind of problems by using the distance formula, these two terms almost always have opposite signs, that term and that term. Because otherwise, if they didn't, we'd be in trouble. In other words, I had them had the same sign. I had y plus 4 and I had 4 plus y. That's the same sign. Everything's going to cancel out and we're not going to have an equation. But if I do it properly, now the y squareds cancel, the 16s cancel, move the 8y over to there and you have x squared equals 16y. And if the teacher wants you to put that in a different format, you could certainly say y equals 1/16 x squared. Although in most school systems in Colorado, that's actually the better format. Because most school systems use this, 4py equals x squared. Well, notice that if that's the format, I can immediately know that p is 4. In other words, 4p has to equal 16. So I'm constantly having to deal with this problem of different schools using different formats here. But in neither of these problems are they asking for the focus. In fact, they've given you the focus in both cases. The only thing they're asking for is the final equation of the parabola. And that's a good answer, but so is that. I don't think you'd lose points if you give them either of those answers.
Okay.
But these are definitely tricky. In other words, you'll notice that I made the mistake when I said y minus a minus 4. I forgot to realize that y was in negative territory. X is in positive territory, but y is in negative territory. Everywhere that I've drawn on this graph, y would be in negative territory, and that makes a difference. You have to call it basically negative y minus a minus 4. Interesting.
Okay.
I wasn't really aware of that. That was, but it's something that you kind of have to logically figure out. All right, let's see. So should I go to the next page?
Can we do 56 all the way at the bottom?
You want to do 53?
56.
Oh, 56 at the bottom of this page? Oh, I see it.
Yeah.
Okay. And 55, I assume?
Mm-hmm.
Are you sure, Mark? Because these, you need to do at least one of these.
Okay. No, we can do one of those then.
I think you should do 53 because I'm not convinced you know how to do it.
All right.
If I thought you knew how to do it, I wouldn't bother. But these aren't that easy until you figure them out, and then they are easy. But you got to figure them out.
Okay.
What's the standard format for a parabola?
Y equals x squared.
Well, let's use the full format that we learned.
Oh, yeah.
Just with some of the previous problems. That's the vertex format, okay? In our equation that they give us, what is h and k?
Is
0, both of them.
okay.
In other words, we don't have an x minus anything quantity squared, and we don't have anything being added to it. So there's no k and there's no h. What we do have is a equals minus 1/32, right?
Yeah.
What's the formula for, now here they're asking for the focus, so here we do need to solve for p. What's the equation? How do p and a relate?
P equals 4a.
No,
Okay.
no. First of all, a equals 1 over 4p. Which means, now solve that algebraically. Tell me what p is equal to.
P equals 4a.
No, it's not. In other words, if I multiply both sides by 4p, then I got to divide both sides by 4a, right?
Yeah.
In other words, if I solve that, I get 4pa equals 1. Now divide both sides. To solve for p, I got to divide by 4 and a. So p equals 1 over 4a.
Okay.
That's always the case. In trig, b is equal to 1 over 2 pi. Well, there's no point in giving a trig analogy. You haven't had trig yet. So. But when you're solving these, this is always the case. If a equals 1 over p, then p equals 1 over a. And the fourth doesn't really do anything. In other words, I really could just multiply both sides by p and divide both sides by a to get this. Okay?
Okay.
So we need to calculate p, and we have a. So how do I do it from here? Over here on the left, what is p going to be equal to?
P is going to be
Do it
1 over 4 times.
Yes, do it step by step. Do not try to do this whole thing and come up with an answer in one step. What goes in the bottom?
1 over 4 times negative 1 over 32.
Right. Now how do I answer that?
4 times, can you distribute 4 times negative 1/32?
Okay, so that becomes 4. Oops. Like that. Now what?
You multiply each side by...
How do you divide by a fraction? How do you divide by a fraction, Mark?
Multiply by the reciprocal.
Okay, it's as simple as that. So this is the same thing as 1 times 32 over minus 4. That's minus 8. So the focus is minus 8. Okay? Now, that's not all they want. They want the directrix, but let's draw as much of the picture as we can at this point. And a picture really helps here, I think. We know the vertex is at the origin because h and k were 0. We know it has to open down because it's a negative a, right?
Yeah.
Well, we just figured out the focus was right there at 0, negative 8. So where's the directrix? What's the equation of the directrix?
0, 8.
Well, that's a point. That's not the directrix. The directrix is a horizontal line that goes through that point. And what we need is the equation of that line, not that point. There is no equation of a point, but anything that's a line has an equation of a line. Okay, and that equation is what?
Y equals 8.
Yeah. Okay, so we got our focus, we got our directrix. What's the axis of symmetry? Also a line.
That's 0.
Here's
Y equals 0.
It's an easy mistake to make because you're looking at the y-axis, but that's not the equation of that line. The equation of that line is x equals 0. Remember that the y-axis is x equals 0 and the x-axis is y equals 0.
Okay.
Whenever you have a line that is on top of one of your key axes, that's a good thing to remember because the mistake you made, a lot of people make that. They call that vertical y-axis y equals 0, but it's not y equals 0. Okay. Now, the only difference in 54 and 53 is a pretty big one, but it's a horizontal parabola. And the way you can tell is always think back to the one you've learned from Algebra 1 on. That's what it is, right? And that is a vertical parabola. Well, if you have instead x equal y squared, that is a parabola that looks like that. It's not even a function. Doesn't pass the vertical line test, but it's still a parabola. And so what you're looking for is which variable is squared. If it's the y that's being squared, it's a horizontal parabola. If it's the x that's being squared, like you're used to, it's like you're used to a vertical parabola. Okay? So we know that it's a horizontal parabola, but we see that negative sign. We also know that the vertex is still the origin, but the negative sign, just like a vertical parabola, the negative sign means pointing down. With a horizontal parabola, the negative sign means opening to the left instead of to the right. So this is pretty much what our parabola is going to look like.
Okay.
And again, I've got to find this point, the focus, and I've got to find this line, the directrix, and then I got to find the symmetry, the line of symmetry. Okay? So let's work on the focus. What's P equal to?
P equals...
What's the equation for relating it to A?
1 over 4A.
Right. Okay. Now here's our equation. Y equals negative 1/16 x, whoops, y squared, and that's x. So A is what?
A is
from our equation.
A equals
-116.
okay.
Okay, now figure out what P is. We're to plug in A into this equation and then solve it.
All right.
I think this is why most school systems like the other format better, is because this is always a little difficult to solve because you end up with this fraction in the denominator. So what is it? 1 over what?
Okay.
What goes in the denominator? What's 4A?
-4.
If this is A, what's 4A?
4 times -1/16.
Okay, so that's -1/4. I'll simplify it also. And what's that equal to?
Multiplied by the reciprocal, that's no.
Well, there's the 1 that's in the numerator. And I'm going to flip that so it becomes -4 over 1. Well, what's 1 times -4 over 1?
-4.
Okay. That's where our focus is. In other words, our focus is at -4, 0. And like I said, it really helps to draw a picture here so you know whether you're opening up, whether you're opening down, whether you're opening to the right, whether you're opening to the left. You should be so lucky if they don't give you an H and a K. And it looks like they won't. In other words, most everything we've looked at so far, the origin is the vertex. And that definitely simplifies things a lot. What's the equation of the directrix now that we have the focus?
X equals 4.
Good. And what is the equation of the line of symmetry?
X equals 0.
Horizontal lines are always y equals.
Oh yeah. So y equals 0 then.
Yeah, that's a horizontal line. It is the x-axis, but don't confuse the x-axis with being an equation in x. It's not. It's y equals 0. All right. So these are all going to depend on you, first of all, knowing which way they are aligned, whether they're up, down, left, or right. And most importantly, you're going to need to remember that P is 1 over 4A and that A is whatever coefficient they stick in front of the squared term.
Okay.
In this case, it's the y variable that's being squared, so the -1/16 is A. And just always plug it in for A to figure out what P is.
Okay.
All right, let's go down to 55. Solve the system algebraically using substitution. Okay. Now, when they call it a system, that means all of the variables, all x's are the same and all y's are the same. So they're telling me this y is equal to this, while at the same time that same y is equal to this. So what's the next thing I should do?
Substitute.
Correct. So read the next line to me.
-3x plus 8 equals x squared plus 3x minus 8.
In other words, yeah, basically you've substituted, but also what you're doing is if y equals a and y equals b, then a equals b. So I'm logically just letting that equal that. And it is by substitution, but okay, so now combine everything and we'll be able to solve for x. we're looking at a quadratic, clearly, right?
Yeah.
In other words, we have an x squared term, we're going to have some x terms, and we're going to have some numbers. So let's write it as a quadratic. What are we going to put on one side?
0.
Okay, always. And we've only got one x squared term. How many x's do we have on the right side?
6.
And how many numbers do we have on the right side?
Minus 16.
Okay. Now that's factorable. Factor that. Step by step. What's the first step?
Complete the square.
No? Not when you're factoring.
Oh,
In other words, factor it into two linear terms. And the first step is to split up the x's.
Yeah.
What you're basically doing is unmultiplying it. In other words, you can think of having two linear terms, and when you multiply them together, you FOIL them, right? Well,
yeah.
This is kind of a reverse FOIL process. And the way I do it is very methodical. There are exactly 4 steps here. The first one is to split up the x's. The second one is to determine both signs of my linear factors. What are they?
Plus and minus.
Correct. And that happens to be the same as minus plus because it's 1x times 1x. So it doesn't matter whether I put the plus here or the minus there.
Okay.
Now, third step, factors of 16 that do what?
Factors that multiply to 16 but add to 6.
Sign in front. Okay, first of all, when I say factors of 16, I'm already talking about two numbers that multiply to 16. So you don't want to repeat that. In other words, you don't want to say factors of 16 that multiply to 16. That's unnecessary. Factors of 16 that subtract, because of that negative sign, to the coefficient of the x term. So factors of 16 that subtract to the number 6. Now what two factors of 16 subtract to the number 6?
8 and 2.
Okay. The bigger of those factors goes with which sign?
The plus.
Yeah, the sign of the middle term. Because we know, now one thing you should always do is check to make sure you got the middle term right. Well, when I'm FOILing these two things, the middle term is always the product of, or the sum of, the inside terms multiplied together added to the outside terms multiplied together. Well, the inside terms are plus 8x. The outside terms are minus 2x. Those added together, 6x. Got the right middle term. I've done it correctly. Now solve it. What are my answers for x? Because that's what it says, solve the system.
X squared minus 6x.
Now, don't go backwards. You just went there. We were just there. You don't want to multiply these things together. You're just going to get back to that step.
Plus 2 minus 8.
We factored them such that I could have two things multiplied together that are equal to 0. Because if I can get to that step, then I know that either that has to be 0 or that has to be 0. It's the only way you can multiply two things together and get 0.
Okay.
So, what's our two solutions?
Plus 2 minus 8.
Correct. And that's your answer.
All right.
All right, 56. We're looking at two parabolas, right?
Yeah.
They said solve it by graphing. Are you allowed to use your calculator in these?
Yeah.
Okay. Well, so your y sub, what kind of calculator do you have, Mark?
TIM star.
Okay, so your first
TI.
function is going to be that one. And then on the same graph, the second one is going to be this one. Again,
Okay.
the y's are equal and the x's are all the same, whatever they are, but I can tell the first function is a parabola that opens down. I'm not sure where it's located. Its vertex is not at the origin, but let's say it looks like that, okay? The second function is a parabola that opens up. Well, might look something like that. The solution is, there's two solutions. This solution is x comma y, and this solution is going to be a different x comma y. But we can tell that two parabolas are most likely going to intersect at two different places. So when you put it in your calculator, you're going to get something that looks like that. Now, do you know on that Inspire how to find these points of intersection?
Yeah, okay. I do.
All right. And that'll give you your answers. Now, let's talk about the answers for a moment. The answers have to be given in pairs. In other words, one answer might look like this, 5 comma 3. In other words, the x and the y coordinate right there. And the other answer might look like minus 2 comma 3. A different set of x and y coordinates. So your answers are not x equal minus 2, x equal 5, y equal 3, y equal 3. In other words, that's one answer, that's another answer. Your x and y coordinates have to go together in a pair. All right, we're covering a lot here. I'm sure your brain is about ready to be fried at the moment. So why don't we finish the rest of it later today? And we may not be able to finish it. I suspect, I mean, we're only on first page out of 4 pages. Okay. Mark, let me caution you about something, that you've got a semester final coming up here in a couple weeks, right?
Yeah.
Maybe 3 weeks. Well, everybody does the same thing to me on the semester final. They schedule an hour session. I'm always fully booked, no openings. And then they bring 3 hours worth of material to cover. Kind of what you've done here. Only at least you scheduled an hour and a half, but you still got like 3 hours of material to cover. So try not to make that mistake for your final. Okay? You know that the review packet that he's going to hand out before your final is going to be 3 or 4 hours of material. Well, let's make sure we do 3 or 4 hours prior to that final between now and then. Let's not wait all and do 1 hour the night before the test and expect to cover 3 hours of material. It doesn't work that way. There's no way we can do that. So if I were you, I would schedule at least 3 hours worth of sessions between tomorrow and over the next 3 weeks, at least an hour a week. And as far as getting ahead of it, in other words, knowing the review material that he's going to hand out the day before the test or the week before the test, we're looking at it right here. A lot of it's going to be the same stuff that's in here. So we can take this material that you have here that you're going to have a test on tomorrow and use it for the next 3 weeks, covering it. And look, so far, it looks like you need to cover every single one of these. You really didn't know how to do any of these. And so we want to go back and cover every single one that we're looking at here, and probably in 4 or 5 pages, and I'm guessing that's at least 3 hours of material. Okay?
Yep.
All right, Mark. I will talk to you at 4 today.
All right. Sounds good.
All right. Talk to you then.
See you, David.